Hello my dear friends, welcome back to the solution of question bank provided by the NBSE National Board of School Education. Class 12 Mathematics, 2 more questions. So I've already solved the 4 more questions for you, which I believe that will be helpful for you. Now in this video, we will be trying to solve the 2 more questions. So since it's only the 2 more questions, we'll try to finish up within one video. So I believe all of you are ready. Back with your pen and paper, and I believe that your exams are going very well. I hope that the mathematics exams will also go very well. I'm sure of that. So please do work hard, practice more. Let's go back straight to the solution of the problems. So the first question, I've written it down for you. So please do practice the question bank. As I've always said, it provides very good revision for you. So it's going to be definitely very helpful for you. Maybe not the exact questions, if you're lucky the exact questions also, but definitely of course similar type of questions. So it does provide the whole revision for the entire syllabus. So please prepare well. Mathematics is all about practice. So in the meantime, I believe all of you are ready with your pen, book and paper. So I've written down the first question for you. That's from chapter 1. That's functions and relations. So basically this question is about composite functions. So the question is, find g on f and f on g if the functions f and g are given to us. So let's get straight to the solution part. Solution. So let's go for g on f. So as we know, g of the function f of x. So that's going to be g. What is our function f of x here? 8 of x cubed. So these are simple questions. So that I'll just write here, then that will be, what is our function g? X power 1 by 3. So what will be our function here? X power 1 by 3. So instead of x, we will be replacing it with 8x. This is x whole power 1 by 3. So now that's cube root, isn't it? So cube root of 8 is what? 2. Cube root of x cubed is of course x. Class 12 standard. So I believe those details need not be explained. So I think that will be enough. 2x. Similarly, f on g, that will be f of the function g of x. So that's going to be f. What is our function g of x? That is x power 1 by 3. So that we will be substituting it in 8 of x cubed. That is 8x. Our value is x cube. Alright, so that will be 8 of cube 3 cancel, 8x. So that's the solution. So one is 2x, the other one is 8 of x. So a simple question done. Okay, alright. You can pause there if you wish. Alright, let's go to the second question quickly. Second question of course is from the binary operation part. So that question is from the reduced part of the syllabus for this year, this session 2021. So that we are going to skip. We'll go to question number 3. Question number 3 is from the inverse trigonometric functions. Prove that twice of tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse of 31 upon 17. So now here of course we are going to need that formula, that is twice of tan inverse x. What was the formula for twice of tan inverse x? Twice of tan inverse x was tan inverse 2x by 1 minus x squared. So we will be utilizing this particular formula for, so let's go for the proof. Okay, let's just start with the left hand side. So that's going to be 2 tan inverse 1 by 2 plus tan inverse 1 by 7. So I'm going to apply that formula here. So that will be tan inverse 2x, x is 1 by 2 here, divided by 1 minus x whole square. So I'll just continue, plus tan inverse 1 by 7. So that will be tan inverse 2 cancel, 1 by 1 minus 1 by 4 plus tan inverse 1 by 7. I'll just continue here. So that will be tan inverse 4 minus 1, that will be 3. 4 minus 1, 3. 4 upon. So 4 divided upon 3 plus tan inverse 1 by 7. Plus tan inverse 1 by 7. So here again we will be using that particular formula. What was that? Tan inverse x plus tan inverse y. So that was tan inverse x plus y divided by 1 minus xy. So we'll be using that particular formula there. So let's use it. Is this done? Okay, so I'll wrap it off. So continuing using this particular formula there. So that will be tan inverse x plus y divided by 1 minus x into y. So that will be tan inverse, taking the LCM, 21, 3 sevens are 21, 4 sevens are 28, plus 7 threes are 21. 1 minus 4 by 21. Just about knowing your formulas only. That's why practice is the key to everything. 31 upon 21 by 21 minus 4, that's going to be 17 upon 21. So 21, 21 cancelled, equated, so that we will be left with 31 upon 17. That's our right hand side, that is the proof, 31 by 17. Alright, okay, so simple question, of course, provided you do remember your formulas correctly. Let's go to the next question again. Next question number 4, that is about again inverse trigonometric functions again. If sine inverse 1 by 5 plus cos inverse x is equal to 1. I'm just writing it in short. Find x, find the value of x. Chalo, let's do it. So sine, this is not proof, okay, this is find x, so solve. Sine inverse 1 by 5 plus cos inverse x is equal to 1. I can write it as sine pi by 2, isn't it? So because sine 90 is 1, isn't it? So 1 can be replaced as sine pi by 2. So sine equating, we will be left with sine inverse 1 by 5 plus cos inverse x is equal to pi by 2. Now here we will require another theorem, that is sine inverse x plus cos inverse x is equal to pi by 2. So similarly, sine inverse 1 by 5 plus positive value cos inverse 1 by 5 is equal to what? Pi by 2. So that means sine inverse 1 by 5 can also be written as pi by 2 minus cos inverse 1 by 5. We can replace that. So instead of sine inverse 1 by 2, I will write as pi minus cos inverse 1 by 5 plus cos inverse x is equal to pi by 2. So pi by 2, pi by 2. So we'll be left with minus of cos inverse 1 by 5 plus cos inverse x is equal to 0. So that of course can be written as cos inverse x is equal to cos inverse 1 by 5. So I'll just continue here. That implies x value is 1 by 5. So our job was to find out the value of x, that is equal to 1 by 5. Okay? Alright, let's move on to question number 5. Question number 5 is from matrices and determinants. Basically matrix, a very simple question there, number 5. Yes, formation of matrices. You should be very lucky if you get those kind of questions. Question is, I'll write down a question for those who don't have it. Construct a 2 by 2 matrix. Construct a 2 by 2 matrix A is defined as by the element Aij, whose elements are given by, it is defined by the element here is defined by Aij is equal to I plus 2j I plus 2j whole square divided by 2. So we need to construct a 2 by 2 matrix. So in the rough, we can just write down A11, A12, A21, A22. So we need to define this for elements. So solution. Let's find out the elements one by one. That will be better. And then lastly, get the matrix. A11 will be defined by this. So 1 plus 2 into 1 whole square divided by 2. So that's going to be 1. 2 ones are 2. 3 square, that's 9 divided by 2. I guess that's alright if I just do the calculation directly. A12 will be 1 plus 1, 2. J will be 2 now. So 2 2s are, okay, I'll just write down 2 into 2 whole square divided by 2. So that will be 1 plus 2, 2s are 4. 4 plus 1, 5. 5 square, 25 by 2. I guess that's fine for all of you. Continuing further, A21. So that's going to be 2 plus 2 into 1 divided by 2 whole square. This 2 is outside that. So that will be 2 plus 2, 2 2s are 4. 4 square, 16 divided by 2. That is 8. And lastly, A22 will be 2 plus 2 into 2 whole square divided by 2. So that will be 2 to the 4 plus 2, 6. 6 square, 36 divided by 2. So that's going to be 18. 18. Alright? Okay. So therefore, required matrix A can be written as 9 by 2, 25 by 2, 8, 18. So this is your our required matrix. Simple question, as I say. You just have to be careful, okay? But sometimes when questions are too easy, too simple, we take it very lightly, and then that's where we mess up with the simple calculations, additions, subtractions, and all this stuff. So you need to be very careful with the simple questions. Don't not to be overconfident, even for a second, especially in the exams. Focus. Question number 6 again. Find. This is again from matrices, equality of matrices. Find x and y if, I'll just write here, 2 times of 1, 3, 0, x, the matrix, plus the matrix y, 0, 1, 2 is equal to 5, 6, 1, 8. So these are all equal matrices, comparable matrices, of course. So we can multiply. So when we multiply, 2 1s are 2, 2 3s are 6, 0, 2x plus y, 0, 1, 2 is equal to 5, 6, 1, 8. So adding these two matrices, because they are of the same order, we will have corresponding elements. 2 plus y, 6 plus 0 is 6, 0 plus 1 is 1, 2x plus 2, 2x plus 2. So we'll have a matrix of 2 by 2 is equal to 5, 6, 1, 8. Okay. Okay, so if you wish, you can write down from equality of matrices. If you wish, you can write, otherwise you can directly do implies also. From equality of matrices, we will have the corresponding elements to be same. So 2 plus y is equal to 5. We just need x and y, so I'll just compare it. You can see here 6 and 6 same, 1 and 1 same. So we just have to find out the values of x and y, which definitely would be proved same. So y will be 5 minus 2, 3. 2x is equal to 6, x is equal to 3. So the value of x is 3, y is also 3. Okay? Alright, let's move on to now the next question. Number 7, of course, is from continuity. That's from the calculus first chapter, first exercise. But that continuity part is also actually from the reduced syllabus for this session. So we're going to be skipping that particular question also. So we will move on to question number 8. That is, find dy by dx if the given equation is x square xy plus y square is equal to 100. So this is the derivatives of implicit functions. So I believe that you remember implicit functions, that remainder part and all. I've done videos on that also. Kindly go through it. So I'll just write directly. No need to write, but just giving you a recap of how we have done things. So differentiating both sides with respect to x. So I'll just begin with the basics once again. Xy plus y square equal to 0, because derivative of a constant is 0, so differentiation of 100 of course definitely would be 0. So differentiation of x square 2x plus derivative of x into y, we'll have to apply the product rule here, isn't it? X into y, so that's going to be x into derivative of y with respect to x plus y into derivative of x with respect to x plus derivative of y square 2y. Do not forget implicit functions, dy by dx, the remainder term will come. So now let's group them together because we need to find dy by dx. So dy by dx, dy by dx, dy by dx. No, this isn't done. Okay, let's write once again. Plus x into dy by dx plus y plus twice of y into dy by dx is equal to 0. So dy by dx, I'll compare this to dy by dx is equal to minus 2x minus y. Okay, I'm rubbing this part. So dy by dx can be written as minus common 2x plus y divided by x plus 2y. So that's going to be, that is your solution, 2x plus y minus of 2x plus y upon x plus 2y. Okay, alright, done. So moving on to the next question. That's going to be question number 9. That's from integration. Evaluate, I'll write directly, I equal to integral of 1 plus log x whole square divided by x with respect to x. Now this is from the topic of integration by substitution. Okay, integration by substitution. So I'll start substituting. That is, let 1 plus log x is equal to t. So now after that, differentiating both sides with respect to x. So that's going to be 0. 1 by x will be dt upon dx. So that means 1 by x into dx would be dt. So now I'll just continue here. Therefore I can be written as 1 plus log x, we have substituted this as t. So that's going to be t squared. Now dx by x, dx by x, the whole term is nothing but dt. So I'll continue here. So I equal to, what is integral of t square by dt? That is 2 plus 1 divided by 2 plus 1 plus the integration constant. That will be t cubed divided by 3 plus c. So that's going to be 1 by 3. T value, bringing back the substitution, 1 plus log x whole cube plus c. Bus. 1 plus log x whole cube, 1 by 3 plus c. Simple questions. Very simple questions. Of course, 2 more questions. You cannot expect it to be too complicated. These are going to be very simple. So you'll have 10 questions. You'll have 10 questions. So try to get all this 10 questions in the exams. Remember, it's not going to be complicated at all. It's really definitely going to be very simple. So 2 more questions. You should understand that you will be generally getting very simple questions. Maybe except 1 or 2 questions which might just require a little bit of your concept just to test your knowledge, but nothing much. Now, again, 1 minus cos x, 1 minus cos x, we know it's 2 sine square x by 2, and 1 plus cos x is 2 cos square x upon 2. That's from the half angle formula of trigonometry that was learned in class 12, if you remember. So straight away just applying the formula, twice of sine square x by 2 twice of cos square x by 2 upon, with respect to x, 2 cancels, so that is tan square x by 2 with respect to x. Now tan square we cannot integrate, so that can be written as sec square x upon 2 minus 1 with respect to x, because we know that tan square theta is nothing but sec square theta minus 1. Just applying that. Theta, of course, here is x by 2. That's all. Okay, I'm rubbing it off. Continuing. Done. You can pause the video here. Chalo. The main thing is you should not panic, okay, during the examination. Just maintain your calmness. Then definitely you will be, of course, I'm sure that all of you will be studying and going. So don't hit the panic button the moment you see the question paper. Take it slowly, take a deep breath, find out the questions which you can solve, and go for those first. Don't think of the questions which you cannot solve. I mean, which you're having some doubts and all. You can do that in the last. First find out in the question paper, you will see, find out all the questions which you can. Go for those first. That will give you some confidence as you go on solving. Okay. Now differentiation of sec square theta. I mean integration. What was the integration from sec square theta with respect to theta? That was tan theta. So that's going to be tan theta. What is theta here? X by 2. So by substitution, I've already told you in the previous videos, in the videos of integration, you can check out those videos. That is, you can substitute and find out, but if you want to do it directly, as I've told you, just divide the value, whole integrand value, by the coefficient instead of substituting for simple substitutions. Okay, minus x plus c. You can check out those videos. I'll provide a link below if possible. So that will be twice tan x by 2 minus x plus c. So this is my solution. Twice of tan x by 2 minus x plus c. Done? So, moving on to the next question. That's from differential equations, question number 11. Find the general solution of dy by dx is equal to 1 plus x square into 1 plus y square. That's differential equations. We will do it by separating the variable method. So dy by dx is equal to 1 plus x square 1. So how do we do with separating the variable in differential equations? What we do is we separate the variables. That's what the name suggests, separate the variables in different terms. X with x, y with y. That's what we're going to do. So chalo, y, x, let's do dy by, I'll bring this y together, and this one, 1 plus x square dx. And after that, what do we do? Now we will integrate, isn't it? That's what we do. 1 plus y squared will be integral of 1 plus x squared with respect to x. So now integration of y 1 by 1 plus y squared, that is nothing but tan inverse y, is equal to integration of 1 x with respect to x, I mean integration of x squared x cubed by 3 plus c. Such a simple question for 2 marks. Definitely. So it's tan inverse y equal to x plus x cubed by 3 plus c. Alright, let's move on to the next question. Now number 12, of course, again is from the reduced part of the syllabus. So formation of differential equations. So we're going to be skipping that. Let's move on to question number 13. If vector A, that's from vector algebra, 2i, 2j, 3k, vector B minus I plus 2j plus k, and vector C 3i plus j are such that A plus lambda b, vector A plus lambda b is perpendicular to vector C, then find the value of lambda. Alright, we'll find out the value. If we remember vector algebra, two vectors are said to be perpendicular if the dot product is equal to 0. So we're going to be using that particular concept. But before that, let's first find out A plus lambda b. A plus lambda b. So A is 2i, 2j, 3k into plus lambda into b minus I plus 2j plus k. So making some arrangement, I, j, j, k, k, like vectors. 2 minus lambda I plus 2 plus 2 lambda j plus 3 plus, that's 1 lambda, I'll just write lambda k. So that's vector, vector A plus lambda into vector B. So now getting straight to the point, since it's given that A plus lambda into B vector, this vector is perpendicular to vector C. It implies that the dot product of this vector and vector C, of course, is going to be what? 0. Alright. Okay, so in that case, dot product, let's go for a dot product directly. This is my vector and C vector is 3i plus j. So that's going to be dot product. I think we can do it directly, isn't it? So I, so that's going to be 3 into 2 minus lambda plus j. J is 1 there. 1 into 2 plus 2 lambda plus k. There is no k there, so that's going to be 0 into 3 plus lambda is equal to 0. So let's solve this. 3 to the 6, 3 lambda, 2 lambda is equal to 0. So that's minus lambda equal to 6 plus 2, 8 minus 8. Moving on, taking that to the other side, right? So of course, that gives us the value of lambda to be 8. Okay? Alright. Let's go to the next question then. The next question again is vector algebra only. Number 14. If vector A, vector B, vector C are unit vectors such that their sum is equal to 0, then find the value of A dot B, B dot C, C dot A. Alright, not a big problem there. It's now given, of course we have to solution. Given vector A, vector B and vector C, they are all unit vectors. That means their magnitude, of course, is going to be 1. No problem. Fine. Also, A plus B plus C, the sum of these 3 vectors is what? 0. 0 or 0 vector also. No problem. Magnitude. Now what shall we do? Using these two informations, we are supposed to find out the value of a dot b, b dot c, c dot a. If you remember the formula of a plus b plus c whole square, that's from where we get a square plus b square plus c square plus twice of ab plus twice of bc plus twice of ac. We are going to use that particular concept here. So what I'll do is I'll square both sides, squaring both sides, or squaring both sides. So that's going to be a plus b plus c into a plus b plus c. It's equal to 0 vector into 0 vector. Squaring both sides and then just multiplying both sides with the same terms. Squaring both sides is the same. So now let's multiply. So that's going to be a dot a. I'll just do all the details. A dot b, a dot c. We can do it directly, but let me just give you all the details. B dot a, b dot b, b dot c plus c dot a plus c dot b plus c dot c is equal to 0, because 0 into 0 vector of course is 0. 0 vector's magnitude is 0, so definitely it's going to be 0 only. Okay? Alright, now a dot a vector can be written as magnitude of vector a square, isn't it? From vector algebra. Similarly, I'll go for first b. B plus next is c plus. Now from dot product we know that a dot b is same as b dot a commutative. Isn't that dot product? Right? So that means a dot b, b dot a, they are same, equal quantities. So that's going to be twice of a dot b plus. Similarly, let's go for bc. B dot c and c dot b, that's also going to be same. So twice of b dot c plus twice of c dot a. Remember that only in cross product these values will differ. Dot product it doesn't, because it's just about magnitude only. So this value is 1, this value is 1, this value is 1, plus twice common a dot b plus b dot c plus c dot a is equal to 0. So that's going to be twice of a dot b, b dot c, c dot a minus 3. 1 plus 1 plus 1, 3. Take it to the other side, minus 3. So that simply will be a dot b, b dot c, c dot a, this value is minus 3 by 2. Bus. Okay, alright, done. I'm rubbing it off. Okay, let's move on to the next question. That's going to be, of course, number 16. Yes. Sorry, 15. That's number 15. That is, find a unit vector perpendicular to each of the vector a plus b and a minus b vector, where the vectors are given a to be 3i plus 2j plus 2k and b to be I plus 2j minus 2k. Another simple question. As we know, a unit vector perpendicular to each of the vectors a, b, as per theorem, is given by vector c divided by its magnitude, vector c. So now, and vector c is nothing but A cross. So now what are we going to do? What is our vectors here? A is considered this A plus B, and B is considered to be A minus B. So we need to find out A cross B, isn't it? That will be our vector C. Right, because the unit vector perpendicular will be I mean, of course, as I said, C upon magnitude of vector C, where C is nothing but A cross B. But remember, perpendicular will have, of course, two directions on one plane. So plus minus, of course, will be required there. It will have definitely two directions. One is from A cross B, other one, of course, will be from B cross A. But remember again, what is the value of A? It's not simply A here and B here. Our vectors are supposed to be A plus B and A minus B. So earlier we just used to have two vectors, A and B. So the questions will be like, find the unit vector perpendicular to the vector A and vector B. But this time here, instead of A and B, it's combination of these two vectors, A plus B and A minus B. So that is how we will be proceeding to solve this. So let's first find out A plus B vector. A plus B. So if we just add two vectors, that's going to be 4i plus 4j. 2 minus 2 done. And A minus B would be 3 minus 1. 2i, 2 minus 2, that is done. 2 minus minus plus. So that's going to be 4. Okay. So A plus B vector, of course, will be 4i plus 4j. A minus B vector, of course, would be 2i plus 4k. Alright, so next, let's first find, we need A cross B, isn't it? So what is A cross B? As I mentioned, A is A plus B and B is A minus B. So that's going to be the cross product I, J, K. Again, I repeat, I expect that you've already done with the syllabus. This is just a revision, so all these things, of course, will be not new, but of course, yes, you can go back and watch those videos which are done in details on the specific topics. I, J, K, that's 4, 4, 0, 2, 0, 4. So cross product revision again. If you remember, as I had told you, I minus J, K. So just like determinant concept, so 4 4s are 16 minus 0 without changing direction. That's why I've already done it by providing minus. 4 4 16 again, minus 0. Here again, sorry, 4 zeros are 0, minus 4 2s are 8. 0 minus 8. So then that gives us the vector 16i minus 16j minus 8k. Let's assume this to be our vector C. So as mentioned, we need the magnitude of vector C also. So that's nothing but 16 square, just the magnitude, 16 square, 8 square. Minus 16 square, that doesn't matter, isn't it? It's just plus only, isn't it? Because minus square is positive. So minus 16 square positive, minus 8 square positive. So that's why we used to write directly positive values only. So 16 square, 256, 64. So that, of course, would be 576. So that value, of course, would be 24. So therefore, the unit vector would be vector C upon its magnitude. So what was our vector C? 16i, minus 16j minus 8k upon 24. You can use here plus or minus. Plus or minus, as I say, a perpendicular can have two directions on the plane. There are many concepts to it. Two directions to a plane, maybe one up, one down. That depends, because we have gone for A plus B cross A minus B. That is one direction. The other direction can be, see, for this, of course, again I repeat, we have gone for a plus b cross a minus b. The other direction can be a minus b cross a plus b. That time, if one is plus, the other one will be minus. If one is minus, the other one will be plus. So that's why just to balance the equation, we just write plus or minus. Nothing much there. It's about a direction only. As I repeat again, a perpendicular can have two directions on a plane. So that will be plus or minus. We're taking 8 common. Two I minus 2j minus k upon 3. 8 3s are 24. So by taking 8 common. So that, if you want to rewrite, can be written as plus minus 2 by 3i minus 2 by 3j minus 1 by 3k. That is enough. Okay, as it is given. 2 by 3i minus 2 by 3j minus 1 by 3k plus or minus. Alright? Okay, so that's it. Next, number 16. Find the area of the parallelogram. Find the area of the parallelogram whose adjacent sides are determined by the vectors. I'm just writing directly I minus j plus 3k. I repeat once again. Find the area of the parallelogram whose adjacent sides are given by or determined by, I'm not writing that part, a equal to this and vector b is equal to 2i minus 7j plus k. Now I can just check what was the formula to find out area of a parallelogram. I'll just have water now. Yes, area of parallelogram. Area of parallelogram was simply magnitude of A cross B, if A and B are the adjacent sides. So that's very simple. So that means we have to find out A cross B first. After that only we can go for its magnitude. So that's I, J, K. What are its values? 1, minus 1, 3, 2, minus 7, 1. So once again, division I minus J plus K. So minus 1, minus 1, minus 1. 7 3s are 21. Minus 7 3s are minus 21. Minus minus plus. Again, 1 1s are 1. Minus 2 3s are 6. Next again, 1 minus 7. Minus 2 minus 1. Minus 2 minus minus plus 2. So that's going to be 20i minus 5j plus minus 5k, or 20i plus 5j minus 5k. So this is my vector A cross B. So the area of the parallelogram would be magnitude of A cross B. So therefore area of parallelogram is nothing but magnitude of A cross B. So that's simply again 20 square plus 5 square plus 5 square. So that's 400 plus 25 plus 25. So that's 450. So 450 to 50. So that's going to be 15 root of 2 square units. 15 root of 2 square units. Alright? Okay, let's move on to the next question now then. Number 17, that's come from three-dimensional geometry. Number 17. Find the vector and Cartesian equations of the lines that passes through the origin and the point 5, -2, 3 of the lines. Solution. I'll just give you the theorem, that is equation of line passing through the 2 points x1, y1, z1 and x2, y2, z2 is given by x minus x1, x2 minus x1, y minus y1, y2 minus y1, z minus z1, z2 minus z1. This is the Cartesian form. C-A-R-T-E-S-I-A-N. Cartesian form. So that's simple. Origin means what? Origin means the point 0, 0, 0. I don't have to mention that, I guess. Origin means the point 0, 0 and 0. So that will be simply, if we just consider this as the first and the second point as per the systematic order. So that's going to be x minus 0, x2 minus x1. So that's 5 minus 0. Y minus 0, minus 2 minus 0. Z minus 0, 3 minus 0. So the Cartesian form is x by 5, y by minus 2, z by 3. This is the Cartesian form. Alright? Okay, now we need to get that vector form. I'll just keep this point. The vector form, the equation passing through 2 points. Vector form is given by vector r equal to r1 vector plus lambda r2 vector minus r1 vector. So r1 vector, that is 0i, 0j, 0k. 0 vector, first point, isn't it? Plus lambda into r2 vector minus r1 vector. Now r2 vector will be, of course, 5i minus 2j minus 3k minus r1 vector, that's the origin, that's already a 0 vector, isn't it? So let's not waste time. We don't need to write also, but okay, I'll just write like just 0, or actually it's going to be something like this in detail if you wish to write. No, not a big deal. Minus 0i plus 0j plus 0k. Not necessary, okay, all these things. But I'm just showing you so that if in the exams, if you have some other points, so that time like you will not be confused. You can do it with other points also. So this is like 0 done. So that's like lambda 5i minus 2j minus, was it minus or plus? Minus 3k. Plus 3k. I guess this is plus because the point was 5 minus 2, sorry. 5, the point was, where is the point? 5 minus 2, 3. So definitely 5 minus 2 plus 3. So that's going to be lambda 5i plus minus 2j plus 3k. I hope that's fine. Alright. 5i vector r equal to. Okay. Alright, so again, if instead of origin, if they give you some other points also, that's going to be the same concept. Since the points, of course, won't be different if the points are different. 18, of course, we are going to be skipping that particular question because again, as per the revised syllabus, the angle between two lines, angle between two planes, those are reduced. So we are not going to do what is not meant for us this time. Let's go to 19. That's about probability. Let A and B be independent events with probability of A given 0.3 and probability of B given 0.4. Question is find, I'll again start with number 1, probability of A intersection B. Now that's very simple because since A and B are independent events, it's very simple. Probability of A intersection B will be probability of A into probability of B. So that's going to be 0.3 into 0.4. Come out from that dot product, come out from that cross product. Okay, now this is just about simple probability multiplication only. So don't think that I get dot product, how am I going to do? No, come out from that. So 0.3 to 0.4, 3 fours are 12, 2 decimals, so that's like 0.12. Alright, okay, done, fine. Next question, that is number 2. Number 2, they ask probability of A union B. So probability of A union B, addition theorem, probability of A plus probability of B minus probability of A intersection B. So probability of A 0.3, probability of B 0.4, probability of A intersection B, just now we have calculated 0.12. So that's like 0.7 minus 0.12. How much will that be? 0.7 minus 0.12, I guess 0.58. 0.58, 9, 10, 70, yeah, 0.58. Because they are independent. Okay, alright. Let's go to the final question, number 20. Question number 20 says almost the same question. Given two independent events A and B. I'm not rewriting the question, it's almost the same question. So given two independent events A and B, find such that probability of A is 0.3 and probability of B is 0.6. Nothing much, they've just changed the value only. 0.6. Find probability of A. Number 1 is find probability of A and B. Now and represents intersection. Since A and B are again independent events, probability of A and B represents probability of A intersection B. So that's like probability of A into probability of B into not cross product. Okay, so that's like 0.3 into 0.6. That's like 0.18. Same question, only the quantities are changed. Alright, done? Chalo, I'm rubbing it off. Next is probability of A or B. So probability of A or B means probability of A union B. So that's like probability of A plus probability of B minus probability of A intersection B, 0.3 plus 0.6 minus 0.18. So 0.9 minus 0.18, 9, 10, that's going to be, I guess, 0.72. Alright, so that's winds up the 2 more questions. There are 20 questions. I think we've done about 17 questions there in total. 2-3 questions were from the reduced syllabus. Alright, so that's it for the 2 more questions. So almost all the questions are done for you. I hope and I pray earnestly that you will do well in your examinations. Alright, so please do practice well. Do not take it overconfidently and all. Like, don't take anything too lightly. And as I say, when you go to the examination hall, please remain calm, be focused. Focus on the questions which you know, which you can solve, and do those first. That will give you a lot of confidence. Then you can try the other questions which you think you can try later. Alright? Okay, and yes, manage your time well. 3 hours, manage it properly. Alright then, till then, I am sure that you are going to do your exams very well. You have my prayers with you. So please do well in the examinations. I'll see you again very soon with the other videos. And yes, finally, kindly do share this channel with your other friends also. And yes, please do hit the like button also if you have liked the video, if it was of any help to you. Alright, okay then, take care, bye bye, stay safe.